Oh, yep. Cool. So welcome everybody to another week of Malware Club. We're just going over real quick how to start up a VM in the iLab for a new member. So the first thing that we're going to need to do to begin with the activities we have planned for today is you need to install the Windows Subsystem for Linux. So just a real quick reminder, you're going to go to iLab, dcu.edu, and then you're going to go projects, projects default, and you're going to start your Flare VM. And to do that, you can either, well, first you'll go power on once it's started. You either click this right here, or you can do launch web console, or if you have the remote console installed, you can launch that too, and you might get a slightly better experience using that. But with that, what you'll need to install is the Windows Subsystem for Linux. And to get to that, we'll actually have to get internet access first.
If anybody has any questions, you feel free to just ask them or type a message in chat.
Yeah, so there should be, if you open Internet Explorer, there should be a internet history entry for the captive portal. So you can just type captive. You'll see these two. You need to click the second one with the UID PHP.
You could also just do captive.apple.com. I'm told that this almost always triggers it, and it should get you to that screen.
One second, I have to actually, I'm so used to just copy and pasting it, and this will actually take me a second to type. Right, so once you've done that, you have internet access in your VM.
Standard password for the malware account on Flare VM is password1 ! Question from Ty.
Yeah, thank you. I always forget to mention that.
I'm sorry, could you repeat that? You said password?
I'll type it in there for you. Oh,
okay.
There you go.
Thank you.
Actually, something that I should mention, if you don't feel like trying to type it in every time, you can actually hit the favorites button. And I was pretty sure, yeah, you can pin the page. Or no, wrong button. So you hit the three dots up here, and you go down and pin this page to the taskbar. So then whenever you log in and you see down in the bottom right that you don't have internet access, you can just click this and it'll take you straight to the captive portal. So to get the Windows subsystem, there's a couple of things that we need to do. So you can just click Windows key and then search for Windows features. And you want this one, the turn Windows features on or off. So you click that and then you'll see this window pops up and it just lists a bunch of different things that you can enable for Windows, like .NET, or if you wanted to use the built-in hypervisor for Windows, you could use that. But what we need is you scroll down and you should see something for the Windows Subsystem for Linux. You just toggle that. And, oh, okay, yep. So is everybody at that point?
Yep, I'm good.
Okay. So then you just click OK, and it's going to install everything. Just takes a minute. But once it finishes, we'll have to restart so that it can, make the changes permanent.
Anybody lost at this point?
Cool. So I guess we'll just click the restart now. And then just get the update information, and it should just take a couple minutes. So this was probably something I should have installed to the VMs before I had them pushed out to everyone, but I forgot that we actually didn't have it installed and that this was something that people might need. And the reason in particular that we're going through all this trouble is that when you install Windows Subsystem for Linux, it basically lets you run a Linux system on your Windows host without necessarily having to go through the process of setting up something using VMware or VirtualBox. So also in that same way, you get a little less features than you would with using something typically like VMware or VirtualBox. So you're not going to have the same access to hardware level or kernel level access that you would with actual VM. But it works pretty well. If all you need to do is run ELF binaries or executables built for Linux systems, which is what we'll be doing today. So once you've rebooted, oops, that's weird. Use Windows key, you're going to search for the Microsoft Store. And then you search, and this is actually surprisingly the easiest way to get WSL installed. So if the Microsoft Store opened, in the top right, there's a search bar, and you're just going to search for Ubuntu. And then you'll just click the top result. And the good thing is that it's free, so you don't really have to jump through too many hoops to get this installed. So you just go install, and you'll get a prompt to add a Microsoft account. You don't need to do this. You can actually just hit X, and then it'll install.
Wait, what did you say? Hit next?
X, sorry. You can just close it.
Oh, X next. Something.
Cool. So when that finishes installing, the next step is to click Launch. And it's going to take a couple minutes to install. But while that's going, you can just right-click the Ubuntu icon down here, and you're just going to want to pin it to your taskbar. So you don't really have to go looking for it again.
Were there any particular tools you were hoping to use in this environment?
Yeah, so I was thinking we just go over using Ghidra and the Decompiler. And then maybe GDB as well, just to show how you might use a debugger and step through different reverse engineering challenges. Maybe even just the kind of like the general thought process for using it.
I guess I meant any tools inside of the Linux environment.
Oh,
Sorry.
yeah, for that, it would just be maybe like using commands like file or GDB. Because for the most part, I mean, it's just going to be, you can actually solve this reverse engineering challenge that we're going to be going over with really just using Ghidra and its built-in decompiler. But another way you could go about it is using GDB as well. It just might be a little trickier. So when Ubuntu finishes installing, you're going to be prompted to create a user account. So, I mean, you can make this whatever you want. I'm just going to call mine malware. And you just click enter. It wants password. Ideally, you should do something that is safe and secure, but I'm lazy, so I'm just going to type root and type it again. And your account will now be created, and you can pretty much use this in any way that you typically would Ubuntu or any Linux installation for that matter. But then one of the first things you have to do with any Linux installation is, once you've installed it for the first time, is sudo apt update. Actually going to try to make the text a little bigger.
You can press down with the control button and use the mouse wheel to do it if you want.
There you go. Okay. Didn't know that. Usually I try like the control plus or control shift plus key. That is handy.
That works for a lot of things, actually.
Oh, okay.
Just the control and then the mouse wheel.
Does it work with Notepad?
Notepad, no.
Oh, okay.
You mean the Windows one or the software?
Yeah, Windows.
Or the
Windows
Notepad plus plus?
Windows Notepad.
No, I don't think so.
Oh, that's a shame.
Sublime, Ghidra, IDA, all kinds of things. Internet browsers.
Yeah, I guess for internet browsers. Yeah, so sudo apt update. Use your password.
So we got a new person.
Hey Ernie, how's it going?
Oh, hi.
We were just going over how to get the Windows Subsystem for Linux installed on your VM. It's something we're going to
okay. I've
need
done
for...
that.
Oh, you have? Okay. Do you need us to go over anything to get you caught up, or?
No, I'll be fine.
Okay. Yeah, I guess just to fill you in, we're going to be using the WSL as a tool to help us run the Linux binaries that we'll be using for our activity today.
Sounds good.
Did you tell them to do sudo apt upgrade?
Oh, might have done that. Okay. Yeah, so after you do the sudo apt update, you need to do apt upgrade, and that's just going to update everything. In the meantime, though, while that's going, I guess I could just talk about what today's activity is going to be. So you can download the files that you need from a couple of places. Either you can get it from the Google Drive under crackmes, and then you'll need this zip, and the password for these zips under the crackmes folder is in the passwords.txt file, and the password is just crackmes.one. The other place that you can get these, if you like the challenge and you want to do more like it, since I don't remember the actual link, you're going to have to go to Google and just search for crackme and crackmes. So the full link is crackmes.one. And you'll get to this website, and just kind of a brief introduction. You don't need to create an account or log in or register or anything to participate in these challenges. So you can either get them from latest crackmes here, and you can just kind of scroll through and you can see name of the challenge, the challenge author, language, difficulty, the platform that it's used for, so like Linux or Windows, so that's going to be like an ELF binary or a PE binary. Then you also get the date that it was uploaded, as well as the number of solutions and comments. The one that we're going to be going over, you'll need to do crackme search if you're not using the Google Drive method, and you're just going to be searching for cbm-hackers. And you can just hit search. And the one we're going to be doing is easy reverse. So you can just click that on the name, and you can see some of the basic information. So it's by CBM Hackers. It's a C++ language challenge. It was published 2 years ago, and it's a level 1. So it's an easy crackme challenge. So you can download it and save it.
If you guys are downloading from the drive from Malware Club, I'd recommend doing it through Chrome if you're doing it in the Flare VM environment.
True. So with that, then you'll have opened it in folder. If you didn't open it in folder from your browser when you downloaded it, you'll just go Downloads from File Explorer. And you can right-click the zip and then go 7-zip, extract to 5B8A, and the password is going to be crackmes.one. And you'll just click OK. So it'll be unzipped and you'll have the folder. There's another zip within it, and you just go again, 7-zip. You can just say extract files this time. You click OK, and you'll get a REV50 folder, and you'll have the actual binary or challenge here. So what you'll do is you can just minimize that window, and you're going to open the Flare folder. You'll do Flare disassemblers, and you'll want to use Ghidra. And we're going to be using Ghidra today because compared to the other options out there, Ghidra has a decompiler, which is going to be a big part of solving the challenge, at least the method that we're using. Other solutions, you might use Binary Ninja, IDA, or Radar, but Radar doesn't have a decompiler. IDA has a decompiler, but you have to pay for the Pro version. And Binary Ninja, I've never used before, so that's why we're not covering it. I have heard, though, that you can connect the decompiler for Ghidra as like a server instance, and you can connect to it using Radar, but I haven't tried that before. So you'll just click I agree, and it'll open up Ghidra for the first time. Well, I mean, if you want to read it, you can do that, but we're not going to be. So you can just close the Ghidra help box, uncheck show tips, close. And so this is the kind of like the main window that you're going to open when you use Ghidra. When you're first beginning any project or task or whatever, you have to go File and then New Project. If you're working on this in like a group with a bunch of people, you would use Shared, and that would allow you to work on it with multiple people and share it with things like GitHub and do like version control. We're not going to be doing that. You're just going to do non-shared project. So next, you'll want to choose a project directory. For that, you can just go Desktop, click this folder icon in the top right to create a new folder, and you can just name it whatever you want. I'm going to call it MC Club. Oops, that was the wrong thing to type it into. MC Club. And then you'll just click Select Project Directory. And then project name, I'm just going to call mine crackmes. Finish. What you'll do is you'll go File, Import File, and then navigate to where we downloaded the challenge. And that was Downloads 5B8A Rev50, and you'll click on the binary there. And this will import the file, and it'll do sort of a kind of cursory analysis of it. But to do that, you just need to verify some of the input information. And one of the things that you choose is if this is just a raw binary, or if it's the ELF format that it detected it as. We're going to keep it as that. If for some reason you disagree with the language that Ghidra has detected the binary as having been built with, you can click Browse, and you can see if I can make this bigger. You can choose the variant or the language type. So it's x86 default, Endian little 64-bit with GCC or Visual Studio. We're just going to keep it as GCC. And then you can also just change the destination folder, which we're keeping because that's our crackmes folder for the project. So you're just going to click OK. It's going to finish loading it. And then you'll just have to click Allow Access for this. And like I was saying earlier, this is the imports results summary for when you import a binary into Ghidra. You get some information like the last time it was modified, the language ID, compiler ID, processor, endian, address size. Some other information that might be interesting is things like number of bytes, memory blocks, instructions, defined data, functions, symbols, or things like number of data types. You can also get information like contents of source files or whether it was pre-linked. And you also get things like the MD5 or SHA. So you can just click OK. And with that finished, we're going to want to actually get to the disassembly part of it. And to do that, you can either click the code browser and then import it again from here, or the correct way would be to do the crackmes folder and just double click on the Rev50. And what that'll do is it'll open this binary that we just imported into the code browser. And then it will ask you, since Rev50 Linux 64-bit has not been analyzed, would you like to analyze it now? And what you're going to do is you're just going to click yes, and you'll be presented with a multitude of different
Hey,
options.
Micah, could I interrupt for a second?
Yeah.
It's kind of a small screen. Could you maybe, if you take your mouse and go to the white part of the, and just do the what I said, the control on the mouse wheel, you could make it zoom in. There you go.
Yeah, is that a little better?
Yep.
Okay.
Or you can maybe even zoom in all the way to the Ghidra.
Oh, sure.
Or what you have there is fine.
Cool. So yeah, so you'll be presented with the different analysis options you can use. And what these are going to do, they're just different settings that you can toggle when the Ghidra is going to read in the binary and try to sort of decipher the different parts of the binary, like imports, exports, anything that it might use to build up your symbol tree. And what you really need to do is just toggle the decompiler parameter ID. And if this were a larger binary, it might take a lot more time to fully analyze, but it's going to help sort of pad out the symbol tree a little. Everything else you can sort of just leave as it's set by default. And what you'll do is just click Analyze. And you can see in the bottom right, the loading bar, it'll just indicate the different stages that the analysis process is at. As for things that might need a little more explaining when you're using Ghidra, on the left side you have the program trees, and this really, it just shows, or it lists the different sections of the binary. Then you have the symbol tree, and this is going to list the different imports, exports, the functions. So you have things like main, printf, puts, string length, and then you'll have things like labels or classes and namespaces. This program doesn't have any, so it didn't detect anything. And then you also have the data type manager, and this sort of just lists the different data types that are being used by the program. We're not really going to go over this for the current activity, so you can just kind of close that one. And then you also get a window here for any like Python scripting you might use with Ghidra. We're not going to be covering that either today, so you can just close that. But we will be going over, see if I can just make the window a little bigger, the different windows that you can open. So what you'll have is right here, this is the sort of the listing view. And it's just really like a disassembly of the program. So you're going to be looking at assembly and how the different registers are being manipulated and where data is being moved to. But for any of these to really make sense, you're going to want to go over to the symbol tree and select the main function. And that'll take us here, and it'll kind of prepare us for the rest of the challenge or the activity. So when you have the main function selected here, you should see these two windows. You'll have the listing and the decompile window. The decompile window is going to show what the raw assembly looks like in decompiled C or C++. You can also select this, and you can kind of turn it into a tabbed view. And you can select between them at the bottom. Or what you can do is you can, you toggle the decompile main at the top. So you click decompile, and you just kind of like drag it down and let go, and then it creates this sort of split view. Or you could grab decompile main, drag it over, and you can just kind of put it up here, or really anywhere that's outside of this main box, and you'll get a separate window. This is just kind of showing the different ways that you can set up the layout for Ghidra. Another view that might be helpful is the Hex View. You can put this below. Shoot, I don't know how to make it go. Oh, well, I'll have to look into that. I don't know how to make it span the entire distance. But something you're going to do for if you're going to use the bytes or hex view is click the wrench icon, and you're going to want to toggle Ascii view, just because sometimes it might help if you're scrolling through. Like right here, you can see the reference to the string for usage. %s password, try again, nice job, flag. So those are all just the different references to the string formats that it's going to use for puts and printf. But we're really not going to be using this hex view either. So for the time being, you can just kind of close that window. Right. So if you've used any kind of disassembler before, you're probably going to be kind of used to just looking at this sort of disassembled view of the main function, where you get the addresses or the offsets, and then the instructions, and then the different arguments to those instructions. So you'll have things like the RBP or EBP. You're seeing RBP here because this is 64-bit, not 32-bit. So you have an expanded register set. So you got things like RSP, creating local variables, jump to another function, or just generally moving data around, like from this local variable into RAX. And it might actually look a little more complicated trying to figure out what this assembly view is trying to do and trying to understand how things flow.
Can you show the display function graph?
Yeah. So up here in our little toolbar here, towards the middle, there's like this little icon that shows a box with like a bracket going down to other boxes. This is the function graph view, and it's another view that you can use. I just gotta scroll up a little. Right, and this kind of is another way that you can look at the binaries and kind of understand the control flow a little better. So it'll show, like when you get to instructions like a comparison and then a jump, if that comparison fails or if it succeeds, it'll show, I'll zoom in a little, it'll show the flow or the path that it's going to take. So you'll have, just trying to see if it, yeah, okay. So you can kind of actually, you can drag these apart if you don't really like how it.
This one, if you do the shift and the wheel, that'll do the zoom. Hold down shift and do the wheel.
I think I'm zoomed in all the way. Yeah, right. Yeah, you can zoom in and out all the way. So just kind of looking at this general flow, sort of one of the first things you would want to do is determine if like you're looking at like a for loop, or if you're looking at like a while loop, or if it's like a series of if statements. It could be like a switch. But right here, since I'll zoom back in again, you don't really see any use of a counter when you're going through, where like EAX or ECX or anything like that is being added to by one. And it's just kind of dropping down from each block into the next, and then maybe jumping out to another function like usage. It's just kind of like one if else to another if else to another if else, and it keeps going down. And you can kind of even see that here with this little string over the line, where it actually indicates that the flow that you're seeing. between one block to the next is actually an if-else statement. And you can see it again there, there, right there, and there again. But where trying to understand a lot of this assembly gets a little easier is if you can actually just close this, is if you use the decompiled view. And a lot of times, at first, even the decompiled view doesn't make a lot of sense. And that's just because you have these signatures that are built into Ghidra. So when it sees a function like main, typically you should have like int argc in or char pointer to argv. But this doesn't have that here, so it gets kind of confusing, and you have things like param1, undefined, param2, and it really messes up if statements like right here. So where you can kind of make that a little easier is if you go here, edit the function signature, and you'll get this. But you're probably wondering, well, how do you know what signature you should use? And for that, what you do, if I can zoom this back out, you're just going to go back to your browser, and you can really just search for a C main signature.
We can't see whatever you're doing.
Oh.
But we see the edit function.
Is my screen not showing, or?
I see what you're doing in Ghidra. I thought you were on a different screen. I'm sorry.
Oh, no.
I can see that now.
Just
Okay.
a delay or something.
Okay.
That's just a bit slower, a bit of latency.
Yeah, that's always fun. So you guys can see the browser now?
Yep.
Okay. Yeah, so you're just searching for the C main function signature. Or another way to search for it might be like main method signature. Then you're just going to look for, I think it's this one, the cppreference.com. And it kind of says right here that you have like int main, int argc, char, pointer, argv, brackets, closing parenthesis, and then the body. So this, well, I guess either this one or this would be the signature that you would use. And what we're going to do is you can just actually kind of copy this right here. So from int main to the closing parenthesis, just go copy. And we're going to go back to the edit function. And you can just go copy all of it, paste it, and you can just click OK. Oops.
I think we have a little bit of a lag on our video, or at least I did.
Okay. Do I need to let it just kind of catch up for a minute, or?
I'd let it wait just for a second here and make sure everybody's caught up.
Okay.
I'd say probably good.
Or you said it was good?
Yep.
Okay. I was checking my notes real quick to see why. Oh, okay. Yeah, so you don't need those brackets there. So you can just click OK once you've changed that signature. And then it'll update. And you should see the changes both in the listing or assembly view, and then also in your decompiled. But what you might notice though is that it's not actually treating argv like a pointer or an array. And to do that, you actually have to make another change to the file signature for that to fully kind of update. So you'll go back to the edit function signature, and what you're going to do is you're going to add another asterisk. Oops. You'll click OK. Oh, shoot. Okay, there you go. Yeah. I'll open that back up so you can see. So what you need to do is add another asterisk there. So it should be char space asterisk space asterisk space argv. And that's what it needs to recognize that argv is sort of a pointer to an array. You'll just click OK. And you should be able to see how big of a difference that actually makes when looking at the decompiled view. Because you'll be able to see that it starts off with, you have int main, where you're reading an int argc, and then argv, which is sort of like the arguments that are read into the program when you run it. And then you'll have local variable svar1, and it's saying if arguments is equal to 2, so where you have like, let me open like a text file. So that's where, like, if you were to run this program, and it would be like, yeah, so this would be 1, length of 1, and then if you include the whole thing, this is a length of 2. So what it's checking to see is if argc is equal to 2, so that means it has a argument following running the program. Then it wants to grab the string length of that second argument. So that's argv1 starting at 0. So if you had argv0, that would be the actual file that's being ran. And if you do argv1, that's the argument following it. And then so it's grabbing that string length, and you're going to do if svar1 is equal to 10. So if the string it's reading in is equal to 10, then we'll drop into this next if, and it'll do another check if the 5th character within the second argument equals @ then print nice job and the flag that follows. Otherwise, if none of those checks are made, or if none of them succeed, you're going to go to this else, or a series of else statements, and it'll jump to the usage function. And you can see here that you get another, actually, what we could do here is we could go edit function signature, and I think this would just be, let me go back. Oh shoot. It should just be, oh. Yeah, there you go. So if you want to go back, you can just click right here, and you kind of just get like a history of the different offsets that you've been looking at within the binary. And I just kind of did this one and then go down to where it says main. So you can kind of see that what you're passing into the usage is another argv. So you can click usage, void usage, edit function signature. And it should, if I remember correctly, just be another char pointer to argv. And then you can kind of just see how that updates. So it's going printf, usage, string, password, argv. And that's going to print out again, puts try again. But none of that really matters. So you can just go back to the main. And since we just kind of went through that, flow of the program, we know that there needs to be 2 arguments. The length of the second argument needs to be 10 characters. And the 5th character needs to be equal to the @ sign. Which brings us to the whole reason that we installed WSL. So if you still have that open, what you can do is you just go /mnt, which is the mount folder. And by default, since you have WSL installed, the entire Windows file system is accessible from WSL or whatever WSL distribution you install. So what you can do to get to any files you have installed on your Windows file system is you go /mnt C. You just kind of click tab, and tab will tell you the different options you have for pathing. So we're going to go mnt /c /users. Username is malware, and then we're in the downloads folder. Yeah, downloads 5B. Make sure you do the / because you want the folder and not the zip file. And then rev50 / for the folder and not the zip. And then the binary for rev50 _ Linux 64-bit. Then you can kind of just hit enter, and it'll show you the else statement that we hit. You can tell just because it's kind of the print format. So you have the usage. This was that %is or s for the argv. So it printed out the second argument or argv1 and then password, and it said try again. So you can kind of just go back here and you can kind of match it up. Since we didn't pass 2 arguments, it dipped down to this else called the usage function, and it passed the argv1, and it printed out those 2 statements. So just following that flow that we talked about before to match all those comparisons, really what you just do then is up arrow for the pathing to that executable, and then you just type in like 1, 2, 3, 4 @ 6, 7, 8, 9, and then that's 10 characters long. 10 characters long. And we have an @ symbol within the 5th character position. And you just hit enter and you get nice job. And for the flag, it just prints back out what we put in, which you can verify again, just looking here. And flag %s for string argv1, which is the second argument that we gave it. So that is kind of just a quick sort of synopsis at using Ghidra to do disassembly and decompilation. And if you really want to see a sort of quick difference between the changes we made and what it initially looked like, you can just click, I think it's Edit, or you can do Control-Z, or you can just click this Undo button. Oops. Undo, you can go Undo again, and you'll see the differences between the changes we made with doing the file signature at the top and how it kind of made a little more sense with just making that signature change. And you're going from like int param, undefined, to actually knowing that what this is doing is just using the arguments and then making several comparisons and checks and then determining what output to give you. So that's pretty much what I wanted to cover today, just kind of go over the basics of using Ghidra, seeing what disassembly looks like, and then decompilation, and then also using WSL to run those Linux binaries. So if you guys have any questions, I'm open to doing that right now, especially if maybe you had any challenges with getting things to run in your environment. We can go over that right now as well.
Could you also maybe talk about things you have planned for the future?
Yeah, so I figured since at this point we've kind of covered sort of really quickly a lot of the fundamentals with doing the different aspects of malware analysis, and then right now, like with reverse engineering, what we'll do after today's meeting, we'll actually be getting into downloading like live, more recent malware samples, like maybe like LokiBot or Emotet, which I guess is kind of an older one, but still fairly relevant. We'll download those and kind of go through the same analysis process that other researchers have gone through, and just kind of discuss that, the kind of thought process for it, and the way to go about it with like different tools, looking for different indicators. When you see like this indicator, what that means and how you should go about it, and how it affects your overall process for attributing those samples. So that's kind of what I have planned for the meetings after this, for like the remainder of this semester. And then maybe after that we can move on to different topics, or just continue to look at live malware samples.
Did anybody who's a club member have any ideas for things that they wanted the club to do? If they could give feedback to Micah, or are they just happy to follow along with live malware or other things that he thinks of?
If you don't feel like talking about it right now, you can also, you can email me or Brizantine too. That's okay.
I am pretty new to malware analysis. I have just a little bit of programming experience, so I'm just honestly happy to be here, get my feet wet, and kind of see how things work. So yeah, anything you want to do is great with me.
Yeah, so if anything that we've covered today or in previous meetings doesn't make sense, or you'd like a little more clarification, you can just reach out to me, or I'm sure any other member in the group would be happy to share whatever information they have with you. Especially like with the disassembly that we did. Like maybe it seemed simple with this challenge in particular, but it's just kind of a way to get people who are new sort of familiar with some of the stuff that we'll be using.
And the nice thing about Ghidra is you don't have to really know assembly to some extent. You could just kind of use the decompilation.
Yeah, that's very true. Sometimes though, with different challenges, you'll run into obfuscation techniques they use to kind of mess with decompilers, so that even though you have this disassembly view and you have decompiled, it'll look like a bunch of garbage until you kind of go through and you tidy up things like the signatures or different bits of information that are missing because like the symbol table was scraped. But maybe that's another thing we could cover for an activity.
Just a quick kind of like high view question on that. So if you're looking at something that's been obfuscated in that manner, how are you determining roughly, how you're going to put that back together? Are you just looking at the function calls and the overall flow of the program, and then determining what's missing?
Yeah, so it's depends on how much information you have and what you're working with. Some cases, like if you're working like with the packed binary, you're going to have like missing import tables or export tables, or really the program you're looking at isn't the final result, and what you need to do is you need to unpack it and then continue your reverse engineering process from there to like finally attribute what it is that you're working with. So sometimes it can be kind of like a tug of war process where you've uncovered a little more, but then really there's sort of like a grander picture of more pieces that you need to pick up before you finish the puzzle. So like one recent challenge that I worked with, one of the things you had to do was rebuild the import table. And that's kind of a lengthier process because depending on what's missing, you need to look at different parts of the binary. So that's like fixing the entry point values or different offsets so that when you run the program or you're using things like a disassembler, it's actually reading in the correct offsets to get the correct file structure. Sorry, that's my cat. Does that kind of answer your question though?
Definitely, yeah. I appreciate that. It's super interesting.
Yeah, if we haven't covered it enough today and you want some more, I have a lot more content like that we shared from the last email that I could give you as well.
Yeah, that would be great. I'd be happy to take a look at it.
Okay. Cool.
And if people also have preferences for like maybe types of malware to look at in the future, like if you were to like Office documents or ransomware or just a particular type, then you can always just reach out to Micah and let him know, and he can try to work that into a future meeting at some point.
Yeah, that's a good idea too. Like to keep things different, so we're not constantly going over the same stuff, and you guys get bored or whatever. But otherwise, I think that's pretty much what I had to cover today. I don't know if Bramwell, did you have any
Yeah, I do have
Alternatives.
one announcement.
Okay.
At the faculty meeting today, our dean, Dr. Patrick Ingebretson, who he actually wrote a ethical hacking book. I don't know if you guys are familiar with it, and it was actually a best-selling hacking book. But in any case, he's creating a hackathon that will occur, I think, December 1st to January 8th, roughly. It's still being talked about. But the basic, and the name may change, but the basic idea is you take some kind of cyber computer science project. Could be writing a paper, could be creating some project or doing something very open-ended, and you spend the month or whatever working on it, and then the final deliverable is like a 5-minute video, and then you produce that, and there's like going to be like possibly a $500 prize, a $300 prize, $200 prize, some gift cards. Some more information will be coming out in the future, but that should be probably a good activity to work on during winter break to maybe get a little bit more money.
Yeah, that sounds really interesting. I know I don't know if it's already happened yet, but I think there's also a similar event to that. Like it's usually put on by Sanford. It's sort of the same deal, but I can't remember if it's like a 1-day or 1-week event, and you have to come up with like some sort of solution to a medical information security sort of problem. But that might be another thing to look into as well. And one more thing that I should probably mention, we are still looking for a vice president for the group to kind of just help with organizing activities. And also, since I'm graduating this year, if you guys all like the club and you want it to continue, that's another reason.
And you graduate at the end of the year, right?
Yeah. Not sure if technically I can continue hosting everything in the spring semester, even though I graduate this fall.
I think you can continue if you want to.
Okay. Yeah.
I
Otherwise,
would just make sure to get the paperwork filed on the club before then.
true. Yeah. Yeah, that's a good point. So if
But that's still a good point about getting another person who could lead, and somebody doesn't have to lead all the time like Micah. He's doing it all the time now, but in the future, if we have more members, it could be something a shared duty among different people.
True. Yeah, that might make things a little easier. Otherwise, I think that's everything for today. So I guess we'll meet again 2 weeks from now on October 28th, and we'll see you guys all then. Cool.
All right, see ya.
Yep.
All right,
See you
thank
guys.
you.